Every single video you're seeing on the screen right now is not real. It is a prediction I made using NVIDIA's Cosmos Predict 2.5. And what is that? It is a world foundation model that predicts outcomes from images, videos, and text. And from there, it's going to create a video that will conform to physics, it'll conform to real lighting, it'll conform to things that have to happen in a world bound by physics and all those great things. And why do I care about that? It's because we're going to use it for simulation of robotics. But today in this video, I just want to show you how to get it up and running and how to make your first predictions using a text input, an image input, and a video input. So with that, let's jump into my computer and start showing you how to use Cosmos 2.5 Predict. Okay, to get started with installing Cosmos Predict 2.5, it will take you to the GitHub page. I'll make sure I link this page in the video description notes. But the first thing I want to make sure is that you see the news, because occasionally I have updates. Not all of the models are out yet. And by the time you watch this, there might be more model options. Things may have changed a little bit. But just you can look through the news to see what else has come out since this video was made in about mid-November 2025. And what it's going to show you is you have like an input image and it makes a video. That's what we're going to run through, or an input video that'll make a new video. And it's predicting basically what happens out of these input scenes. And there's also a text variant, which we'll run through as well. But at this point, we just really need to get this installed so we can start playing through those different modalities and doing predictions. So as I come down here, there's a couple things you'll need to look at. There's the setup guide. That's really what we need. The rest of this we can kind of skip for now. Just go to that setup guide. And this is fairly easy. You will need an NVIDIA RTX, it says 30 series. I think you really need a 5090, or you need maybe slightly more than 24 gigs of RAM. I'm not sure, but you can go ahead and try it out if you have only 24, but you won't be able to get away with less than 24 gigs of RAM. You need a NVIDIA driver. That's 571.24.06 or better. To check that, you just launch terminal and type in NVIDIA-SMI. And you can see I'm on 5080, and I think I needed 5070. So I have at least a good enough driver here. So that works for me. If I go back to here, you need to be on Linux, which we are on Ubuntu. I found that 22.04 works really well. 24.04, I'm not 100% sure will work, but I think it does. And it says here, yeah, if you have that, you'll have this also. And then Python 3.1 or 3.10, I think I have that. So if you go to Python 3 -- version, it'll also let you know what you got. Yeah, I have 3.10. If you don't have any of these, you can go ahead and just like type in ChatGPT how to install these. You do not need CUDA Toolkit 12.8.1 pre-installed. It will be part of the package that we will install, and it'll run it at runtime. So that's one nice thing. So then we're going to clone the repository. That's basically just getting the data, and you're going to run this git clone in terminal. But what they have here won't run for you most likely. What you have to do is go up to this Cosmos Predict at the top and just get back to the main page. Go to code and then copy this HTTPS. And so you're going to do git clone in that location, and it'll pull all of the data. Should only take you maybe 30 seconds or less. It's already done for me. And then once you're there, you're going to go back, and we're going to change directory into that. So we will be working in a folder called Cosmos Predict 2.5, and that's where we'll be now working out of. And it will be in whatever home directory. You could put that somewhere else if you know what you're doing. And then we need to install these dependencies. So we're just copying and pasting at this point. And I see that I have made a mistake by putting that curl in there. And then you just put in your password. So, and it will upgrade. I already have all these, so it says nothing was upgraded. And now we're going to set up it's called a virtual environment. So again, we're just going to copy these. You can hit that button. It can run both these at once. And it's going to set up a virtual environment for everything using UV. It doesn't take very long. And then the last thing we need to do is install it. So just last line. And like that, I have Cosmos Predict installed. It's incredibly fast. Might take a little longer on your computer, but probably not a lot of time. And I'm going to clear this, but you can see how it says Cosmos Predict. It's kind of like content environments, if you understand that. If you see this, it means that you have basically Cosmos Predict running. So you need to be able to see that every time you run this. Let's say you get out of that. For example, let's just close my terminal. If you want to get back in, first thing you need to do is path back to your Cosmos dash predict 2 dash predict 2.5 folder. And then you will need to run this line here. It says source virtual environment bin activate. You run that, it will then start up your virtual environment for Cosmos Predict. And that's all it takes to install this. You do not need to worry about using a content package unless you really want to. Or they also have here for a container toolkit. You can do that if you know what you're doing. Again, that's kind of advanced. If you understand that, you probably aren't needing this tutorial. The next thing you're going to need is you need to download the checkpoints. I'm going to skip line 1. Let's skip line 1 for right now. What you need to do is install Hugging Face command line. So we're just going to go here and we're going to copy this little line, put it in there. And then we need to log in to Hugging Face, which again is that next line. And we'll need your input token. That's what this was about. So if I go here, I'm going to open a new tab. You're just going to log into your Hugging Face account. If you don't have one, you're going to create it. And then you have what's called user access tokens. And you can hit create new token, put in read, and then give it a token name. So you could call it like Cosmos Predict, whatever you want, and hit create token. I already have created a token. And if you already do have one you want to reuse, you can just go here and say validate and refresh, hit OK. And I will have this blanked out, but there will be on there a token that you can copy. I just don't want everyone to get mine. And then from there, you're going to go back to terminal. You're going to paste that in. You will not see it when you paste it in because it says input will not be visible. Yes. And then you're good to go. So it will know how to download your model. So every time the first time you launch this, it'll download the model. The next thing you need to do is this is open model license agreement. So if I go again, I'm going to open this new tab. It'll bring up the Cosmos Predict 2.5 2B model page. And you will see an area here where you'll need to say, I will not use this for things that are against their usage policy, and then it'll grant you access. And then there's some really good information in here as well about the model. One thing I will talk about in a few minutes is the input output specifications. This is something that you probably want to read through, because then you'll know what kind of file types we can use for this. And with that, you have everything all installed, ready to move on to using it. That's pretty quick, wasn't it? Now you have everything installed. I'm going to show you how to run inference, and that's basically generating your predictions. I'm going to go back to this Cosmos Predict link at the very top. This is the easiest way to find how to run the software. And you're going to go down to the inference of the user guide. And this will basically tell you how to run Cosmos Predict 2.5. It looks a little daunting if you're not used to looking at readmes like this, but I can tell you it's actually pretty easy. They give you a bunch of parameters that you can set, some predicted outputs of what you would expect from these, and how to run to get these. But one thing I'm going to do is run my own and use the examples I have so you can make your own, because if we just run the examples, you don't really learn anything. So since we built this project, you'll notice that there is an assets folder. When you go to the Cosmos Predict folder, you downloaded and installed. And in there, there's a folder called base. And base has got a bunch of sample assets that we can use to learn. And there's a few in here you won't recognize if you're looking at your own screen and wondering where these all came from. Because a few are actually ones I made that I'm going to show you how to make those from scratch so you can also follow along to your own data. So we're going to run through these. There's several variants. There's text to world, image to world, and video to world, which I mentioned at the start of this video. And we're just going to run through each one at a time. And then at the end, I'm going to show you how to run, let's say, multiple text to world, or run all three of these all in a row, so you don't actually have to sit here and run each one by one. So let's start with text. Text is obviously the easiest. All you need is a text prompt, which is a txt file. There's one in here called snowystoplight.txt. I'm not going to read this all to you, but just it's in there. It's basically saying like a stoplight in the snow on a road. And then you're going to need what's called a JSON file. And a JSON file is basically setting up each prompt project. So if I go open this in a notepad, you'll see it says inference type, text to world, name of this project run, snowy stoplight, and prompt path, snowy stoplight.txt. So basically, we're just saying what's the type, the name of this project, and where is that prompt. And that prompt is that txt folder we first looked at, or txt file. So if I go close this, I want to make my own. So to make your own, I created one called car driving. I'm gonna actually delete the JSON that I have created and create a new one for it. But I went ahead and created my own txt file, and it's basically a red car driving down a snowy street. The light outside's dark, a little snowfall. The scene is in a large city with no cars on the road. So very simple. If you don't know how to create your own prompt, there is some tips I believe in here about how long they should be right here. You want them to be under 300 characters, not so you don't want to write novels, but you're basically going to create that text file, and then you're going to have your JSON. So if you take the snowy stoplight JSON, and we're just going to copy and paste that, I'm going to rename it to car driving. That's the one I want to call this JSON so I can keep it straight. And if I edit it in Notepad++, you'll see it says inference type text to world. I'm going to leave that. This, since I'm going to call it car driving the same as this file, so it makes me easy for me to remember everything. And then that text file was called car underbar driving, like so. And so now we have hit save. Now we have your new JSON and the text file. And one thing I'm going to show you is you can actually make a new folder in here if you want to keep all your data straight. I'm going to call it car driving. As long as these two things live together in the same folder, then everything will run correctly when we go to run the prompt. So now we have this all set up. We're just going to launch our terminal again. It looks like I've closed mine. So one quickly, I'm going to jump into it. Okay, so now I'm in my terminal, and I basically just go back to the instructions page, and we're going to run this first example asset, this first line here and the example section. Basically, this will run anything you need. And we're running basically a Python script. So you run Python examples.inferencepy. If I just copy that section into here, then we just need to add our own custom data. So if you go, I'm actually going to close this notebook here, and it says we need -i. So that's basically saying where's the input file. So I'm just going to do -i. And then I always like drag and drop because I usually type things in wrong. You're just going to put that JSON file in there because that's what's telling everything how to run. And then your output folder. So we want an output folder like so. And then they have called outputs like so. I'm going to just have what they have here. I'm going to call it text to world, base text to world. I don't know, something like that. I called it something else when I did this ahead of time, so you don't have to watch this all run. And then they also have the inference type. I found that if you just leave that out, it's going to run without any issues. It knows the inference type from that JSON file that we had already set up. So we're just going to let this run, and I'm not going to run the whole thing, but what it does is it starts loading up all these model checkpoints, and then it'll start training in a second. And once it starts training, I'm actually going to kill this, and so you can see the result without having to sit here and wait. Okay, so now if I go to my outputs folder, in your Cosmos Predict, there's an outputs folder. I had called it car driving, so I know which one to find, but I outputted this video, this prediction video. So again, it was supposed to be a car driving on a dark, snowy urban area. It said no cars on the road. I guess it's on this road, but I still saw lots of cars. But still, overall, pretty cool how I was able to do that. Do notice that the output of these are not super high resolution. I go here, you'll see it's a 5-second video at 1280 by 704 at 16 frames per second. That is what you're going to see with all the output. So that's pretty easy how to run text. Image will be a little harder to run because you have to not just deal text, but you have an image, and the image has to be the right size. So if I just clear, they're going to clear this first, and then I'm going to go back to that Cosmos Predict 2.5 assets base folder. And there's a couple different images of like this robot welding image that you can use, and this bus terminal JPEG. And what you really want for input is it to be matching this one, 1280 by 704. And I want to use my own image, not one of these. I use this robot head, which just happens to be the right size, but it wasn't originally. So how I like to resize images is I use Figma, but you can use any sort of image editor. And I'm just going to open up Figma and show you one of the projects I have done. So this is Figma. If this is new to you, this is you can use this as a free account. I'm just going to delete what I have here. But if you type in the letter A, it creates what's called an artboard, or you can go down here and you can say a frame, basically a frame here. And then you're just going to create a frame. And then you want to make sure it is 1280 by 704. And you got the right dimensions. And then I can go grab from my downloads folder. I have here's the original image, which is huge, as you can see, compared to that size, target size. So I can just resize this quite a bit. And then I can pop it into that frame and then resize it some more until it kind of fits. And you'll see how it's going to do a crop. And you can use all kinds of different editing tools to do this. I just found that this one was always easy for me. And then I renamed this robot head, because that's what it was. Oops, misspelled that. And then click export at the bottom here. You want to make sure it's a JPEG. It can be a PNG, but when I do this, sometimes has an invisible layer that you don't want. So I just want to make sure I'm exporting this frame and at 1x, and it'll download it called robot head, and it's the right size and everything. So now I can go and put that file into my Cosmos Predict base folder here that I was in, that Cosmos assets base. I have the robot head. I will need a new JSON. I'm going to delete the one I have so you can see how I make it. So I'm just going to pick another one of these that has an image. So robot welding has an image. So I'm going to find the robot welding.json. I'm going to copy and paste that and rename it to robot head. Again, if I keep everything the same name, I know it all goes together. And then I'm going to open this in Notepad++. Okay, so this one is image2world, name robot, not welding, but robot head for the name. The input path was robot_head.jpg. Now, if it was a PNG or something, you would have to change that extension. And then you need a text. So I created a text file as well. Again, you can create a text file in Notepad. I don't need to necessarily show you guys how to do that. I'm going to save that. Go here, you'll see I have then a robot head text file. And again, it's just a friendly humanoid robot with his eyes that glow, and he's going to turn his head around and from side to side, things like that. So nothing too crazy. I came up with that prompt by just using ChatGPT. So I have these three files. I'm not going to put them in a subfolder this time because you don't really have to, but if it keeps your data all separated easy for you, then go ahead and do that. And then I'm just going to run this eval one more time. And I'm just going to copy all the way up to the I. Go to my terminal, paste that. I'm going to go grab that JSON. That. Then I want my output folder. And this one, let's do it a little different. Let's grab what they have here. Outputs. This. Let's grab what they got. But let's just call it robot. Like so. And I don't need to put the rest of that string on there because it knows within that JSON what type we're running. So there it is. It'll start running. Again, I'm gonna cancel this because we don't have time to sit here and watch this. This on average takes me on my RTX 6000 Ada about 19 minutes per generation. All right. So it's killed. It'll show you the output. So if I go back here to my outputs, I will see here's I created one called robot head. There's the robot head, and he's moving his head back and forth. Looks pretty lifelike. Nothing too complicated, but just showing you that it works pretty easily. So the last one we want you to do is a video. So video is, again, kind of the hardest. If I go to Cosmos Predict 2.5 on Hugging Face, and we look at the model information, it's going to give us some information as you scroll down here to it says input output specifications. Again, this is where it talks about how you want your prompts to be 300 words and should provide descriptive content fewer than 300 words. And then you need this 1280 by 704 for input images, but that's also for video. So video should be that same resolution. But unless you want to run this 480p model, and then it should consist of 5 frames. So they need to be at least 5 frames. I've been running ones that are a minute long, which we're going to use in this example. Just know that if you run one that's a minute long, it's only going to look at the last 5 frames. So it's going to basically append information off the end of your video to predict what's after that video. And so that's what we're going to do. And so I have an example video. I believe it's in my videos folder called driving. And I'm going to delete this one because we're going to make that one. But this one called driving. And if I go to the properties of it, you will see that it is the wrong dimensions. It is the wrong frame rate. So the easiest way to figure out how to change those, get that the right size, is use FFmpeg. And I'm a big fan of just going to ChatGPT and saying, how do I convert an MP4 video to 1280 by 704 with 16 FPS with FFmpeg. And if you don't have FFmpeg, ask ChatGPT how to install it. It's super simple on Ubuntu. But here I'm going to hit copy, and I'm just going to copy that and then go back to this folder. You right click in this bar up here, open in terminal, then we're already in that directory. I can paste that. And I just need to change the input from this MP4 to this. Drag it in, or you could just type it in. And then I'm going to call the output, we're just going to call it driving. Oops, misspelled driving, but that's fine. It runs, and that's how quick it is. So if I go back to that folder, we have that driving folder, and it'll be the right size, perfect for what we need. It's a minute long, but if you go to the properties, you'll see that it is now 16 frames per second, 1280 by 704, which is an interesting aspect ratio. And that's all we need. So we're going to use this. I had already created this and put it into the Cosmos Predict 2.5 assets folder. So I don't have to do that again. But then you'll also need a text. So you want to say, what do you want it to do after the end of that video? Is he going to turn? Is he going to have another car pass by? Is he going to try to pass up a car? Whatever, something like that. Maybe, I don't know, the weather changes. So make sure you describe that in a text. And then you're going to need a JSON. So I'm going to delete the current JSON. I'm going to grab this bus terminal one. Just going to copy and paste it. I'm going to rename it driving so it matches the rest of my files. And edit that in Notepad++. And then now you see, I grabbed an image to world, but we can fix that. We want video to world, and then input path. We want to call this just name driving. Life easy, just copy and paste this stuff. Driving dot. It's an MP4. So this is what happens if you grab the wrong one. So I'm just gonna keep with it, like so. Save. If I were you, I would have actually grabbed this robot pouring one, because that is more what we're looking for. Where you can see it says video to world, robot pouring, and then it's the same. They're not very complicated files. Go ahead and close that. And then we're going to run our prompt one more time. Let's make sure I got the right one here. And then I'm just going to go back to my instruction set. Gonna grab all this. If you want, here's a shortcut. We can just grab all the way up to here. Gonna copy, gonna paste this, and instead of robot pouring, we already know it's in the same folder as that. We can just call it driving. And then the output base video to world. I don't know, or test, enter, and it'll start loading up your models and run the training without any problems. So that's pretty easy. I'm not going to let this run again because it'll take about 20 minutes. But if I kill it here and clear the screen here, we'll end up with an output. I'll show you what that looks like. Go to here. I'm going to go to outputs. We have a driving output. And it's this car driving. And it's pretty good. It even kept the speed the same. Didn't do anything too crazy with text. Even had this good reflection in the window. I think it does a really good job with these video predictions after the end of a video. So that's what that looks like to run that prediction model. So now you know how to run the 3 different modalities. Let's say I want to do multiple of these at once. That instruction is just slightly further down. I do want to notice if you do have multiple GPUs, you can add this line and we'll run on all your GPUs at once. But let's say we want to run all at once. They give you this example assets to run multiple, and you're going to use, instead of Python, and use a torch run. If I just copy this, well, first when you get the data ready, we'll start there. I'm going to go back to my Cosmos Predict 2.5 folder. In the assets folder, I took some of those assets and I put them in what's called a batch folder. It's just knowing I want to run all these. I have a video, an image, and a text prompt version. And so if I want to run all those, you just throw as many of these pre-set up files in one folder and then go to here where we're going to run torch run. And then if I go space back here, I'm going to skip this line because I only have one GPU. And then we're going to just copy out the rest of this. So, and it's going to basically say it's going to run inference.python. The input, I created a batch folder. It's not that base folder anymore. And it's just going to wildcard look for all the JSON files and run through them all. And then I can output this to something called like batch run. Enter. And we're not going to sit and watch this all again, but it's just then going to sequentially run through all these. So if you have like 10 at 20 minutes apart, you know, it might take you 200 minutes. It might take you a couple hours. Unless you're running it on like a server where you might have multiple GPU, or you're using something like an H100 where it's just going to run faster. Okay, so I'm going to go ahead and, so I'm just going to close out so we don't have to watch that all. And then if I go back to my predict folder, my outputs, I had a batch folder where you can see it did all 3 of these tests for me, all in one run, only one config file, all that, because it was all contained in there. And there you go. You had your 3 different outputs all in one. And if you're really inclined, if you really want to dive a little bit more into this, you can always run this Python help, and it will give you a list of other parameters that you can tweak and run. But from there, if you know how to run this much, you can run the rest of it pretty easily. So that's basically how you run Cosmos Predict. Do keep in mind that was all with the 2B model because 14B hasn't come out. And with that 14B, you most likely will need a bigger GPU. Okay, so there you have it. There is just how to run image, text, and video to world models using just kind of the base canvas that they give you with Cosmos Predict 2.5. And this is using the 2B model because that's all that's out yet. I will be doing follow-up videos. I would love to do the auto multi, the robot. But again, today it's just like, how do I get started on that learning journey? But I hope that what you saw here is enough for you to go and play with it and test it, and perhaps even go deploy it on the cloud, because there you're going to get much quicker results, or if you happen to have one of those RTX 6000 Pro workstations. So where are we going to use this? This is going to be very helpful at Lightwheel, where I work at. We're already using this to test out for doing sim to real and coming up with more options. If I get, let's say, 1 hour of sim data, can I make 100 hours of sim data by just making more predictions of different outcomes and seeing if that helps? reinforce the training of a robot. And right now it's looking promising. There's a style transfer video, which I will also have when that comes out. I'll probably make sure it's linked probably right there in the video once I'm at that point. So if you found this helpful, please like and subscribe this video. Leave a comment, let everyone know how good this video was, because I'm going to do a lot on Cosmos. I think it's really going to change everything for robotics and for autonomous vehicles. And that's important. And there's just a little bit of a knowledge gap because you don't know how to get into it. So with that, thank you for watching, and I'll see you guys in the next video.